100% sure, but we'll see soon enough. So what we have an in-circle, A, B, C. I is the center of it, and what? Why did that happen? And B and E are these points. So it touches BC and AC at D and E. Let me delete that. This should be D, and this should be E. I don't know if we want to make C at the top, but I'll figure it out in just a sec. So M is on the in circle with BM parallel to DE, which just happened to point D. Oh, point D must have vanished when I moved the figure. Yeah, it's a little annoying, but can I get it? Oh well, I'll just draw it again. That's D. And so BM is parallel to DE, and it lies on the circle. And it, so maybe we want something more like that. So this is M. M and B lie on the same half plane with respect to the bisector of ACB. Okay, so we want it to be more like, I'm trying to think. We want it to intersect the circle, but we want M. How do we do this?
You just take the other intersection.
Oh, you're right. Good point. That was silly of me. So this is M. We'll just draw this intersection just because, I don't know, maybe it'll be useful. I don't know, but because that gives us an isosceles trapezoid. F and H are the intersections of that with BM and CM. Oh, they already did F, so I got lucky. This should be H, G, H, and J is on AC such that JM is parallel to EH. All right. And it's on the line AC. So we could draw an obtuse triangle if we want, so that it's on the segment AC. So that's H, or that's J. And K is the intersection of JF and the circle. We draw ray. And we want to show ME is parallel to KH. This problem looks a little familiar. So that's ME, that's KH. Okay. I think that's a good enough figure. So DE is the polar of C. So a lot of equal arcs here. Arc MD equals EF. And we want to show MH. Arc MH equals KE. So it's probably a lot of symmetry here.
Yeah, you can, for example, intersect FC again with the incircle, and you get a bunch of you get another another two parallel segments, FM and that H, and they also intersect on CI.
CI?
Yeah. Oh, and by they I mean MG and FH, sorry.
Oh.
And that's actually pretty easy to show, all of that. So if you just let by Brocard, the intersection of FH and MN lies on the polar of C, which is ED. And so since FM is parallel to ED, then NH is also parallel to ED.
Did you say NH or sorry? So you used Brocard somewhere, it sounds like, right?
Yeah.
Okay. So all right. So yeah, let's see. So how did we define? We let CF intersect the circle at G. That was the first step, right?
Yes.
Okay. And okay, so by symmetry, because since CE and CD are both tangent, then by symmetry, GH has to be parallel to FM. So then by symmetry, those have to intersect on an angle bisector. That's how we start getting all that information, right?
That makes sense, yeah. I think that works as well.
So then we know that these all concur. And once we know these concur, and we also know that this is parallel, that all just is true by the symmetry, because CD and CE are tangent, and BE is parallel to MF. So ME, we want to show it's parallel to KH. It's probably just like an angle chase from there. That we have to use point J somehow, though. So we have to use that JM is parallel to EH. So that would mean that this angle, that would mean that arc NF is equal to arc DH. We want to show KE and HF are parallel. That would solve it. We could show that they make the same. There's a whole bunch of different ways to think about this. So yeah, I just have to figure out how do we use that J lies on AC. That seems like an important part of the problem. because that's how K is defined. So we need to use that J lies on AC. One sec, guys. I'll be right back. All right, thanks for waiting. I'm back. So yeah, there's one step I feel like we're missing. We want to use that JM is parallel to EH. And also that JF and E are collinear. Is there something special about this point J? I guess CE over CH is CJ over CM. I don't know if that's useful. Or angle CEH. Okay, so angle CEH is tangent, so that would be equal to EMH, which is EJM. So I guess that means that if we draw the circumcircle EJM, then CM would be tangent. But I don't know how helpful that is. Maybe.
The problem is equivalent to showing MFJ, that circle is tangent to AC. The rest you can angle chase.
Or you mean MC?
MFJ.
Oh,
The
MF.
circle of, yeah.
Okay.
And when I drew in that circle, it just happens to be tangent to CB also.
CEB. That's interesting.
To line CB.
Okay. So maybe we could somehow use a homothety. It's a good observation. And yeah, it's also equivalent. Well, but let's first try it that way. So we want to show so angle FMJ is equal to angle GHE, which is GFE. So it's the same as showing we want to show GE times GJ. Well, we know CE squared is CG times CF. So we want to show EG is parallel to JF. And maybe that's obvious. Yeah, there's just so many things here that are equivalent. No. Yeah, there's just tons and tons of equivalent things. Like we could show EG is parallel to JF, which is equivalent to DK parallel to MG. This problem makes me dizzy, but I don't think it's really should be that hard. What was I showing before? There was some other quadrilateral that looked cyclic. I forgot what it was. JFN and something else maybe? Or let's see. I can't remember what it was. So EGH, like a homothety would take like EGH to JFM, or we want to show it does.
Okay, let's define O as a point on CB such that MO is parallel to HD.
Okay.
Then we have that DH is parallel to OM by definition, and HE is parallel to MJ.
HE is parallel to MJ. Yes. So a homothety.
Those are So homothety by homothety we would have that circumcircle of OMJ is tangent to CB and CA.
And that same homothety takes G to F because in fact, do we even let me think about this. Like
I was thinking of showing that the GF is equal to MO.
GF is equal to MO.
Yeah, and using that and that OJ is parallel to MF, we can show that OJFM is a cyclic, but it is isosceles trapezoid. So that's why it is cyclic.
Okay, because angle JFM and OMF are equal.
Yeah, and that will finish the problem since I had an angle chase from which this tangency was equivalent to the problem condition, like the thing we want to prove.
Okay, so you can show that JFMO is an isosceles trapezoid.
Yeah.
If we can show that, then it's kind of easy because like that it's homothetic to EGHD, right? And so actually
Not sure, but I had an angle chase.
okay. All right. So yeah, it's really just how to write this. So we'll define O that way, right? And then so how do you so first, I mean if we define O this way, then we know it's an isosceles trapezoid because it's homothetic to EGHD, right? So
Not sure if you can say it that way.
oh, because you don't know E goes to J yet.
We know that E goes to J, but we don't know that G goes to F.
But if H goes to M, then G has to go to F by symmetry.
Yeah, maybe then it is actually trivial, that part.
How do we know E goes to J? Or are we just saying, are we starting with a homothety that takes E to J?
You have that OMJ and DHE are homothetic, I think, since MJ is parallel to HE and DH is parallel to M.
Oh, that's right. So we start with that.
That is true, right?
Yes, because this is parallel to this, and this is parallel to this. So we start by saying those are homothetic. If those are homothetic, then because it takes H to M, by symmetry, it has to take G to F, because everything's symmetric about the angle bisector, right?
Yeah.
And so then we have that this is cyclic, and it's tangent to both. And then, is it just like an angle chase after that?
Yeah, I will tell the angle chase after you write the first thing.
Okay. Let the parallel from M to DH meet line BC at O. And then we have MO is parallel to DH, and MJ is parallel to HE. EHT is homothetic to JMO at C. So CD, C lies on the perp bisector BE, so it lies on the perp bisector FM. So by symmetry, C, G, and E, F are linear. So C lies on the perp of BE, and FM is parallel to GH, is parallel to BE. And that means that F, G, and C are collinear. By symmetry, the homothety takes C, G to G to F. Okay. And then it's just an angle chase. I wonder if we even need point O. That's what I'm wondering, because FM is parallel to HG and JM is parallel to HE. So is that enough for the homothety? Like, do we need point O?
I was muted.
No, sorry.
I just said that why would we change now?
Yeah,
What we already.
We don't need to change what we already did, but I think O might be irrelevant. But we could like I don't like if your angle chase uses O, let's just stick with it.
No, it doesn't use it.
Oh, okay.
Okay, so we need to show that MEHK is an isosceles trapezoid. that would be equivalent to showing that
They're parallel.
MEH, actually MHK, that is equal to EMH. No, that's not true. Actually, yeah, your points are a bit different on the diagram. Let me just see.
Okay.
So we want to show that MKH is equal to yeah, MKH is equal to EHK.
Okay.
So MKH is equal to MFH.
Okay.
And by using this tangency, we have that MFH is MJC.
MFH is MJC.
That is actually not true. I just switched H and K. I thought that G, F, and H are collinear. Yeah, collinear, but that's not true. Okay, so we would then just look at angle MFK. So angle MFK, that is equal to MJC, right?
Angle MFK is MJC. Yes.
And by this parallel thing, we have that MJC is HEC.
MJC is what?
HEC.
HEC. Yes.
And that is HME because C is tangent to the incircle.
Okay. So HME.
So we have that MFK is HME, and that basically solves it. We have that MK segment MK is then equal to HE, and that's it.
Okay. So I'm gonna write this on paper. So angle MKH equals angle MFH equals angle.
No. We have that MEK is MFK, and that is MJC,
Okay.
and that is HEC.
EH. Just writing it out. So if we could show, so are we showing MEH equals EMK, or are we showing K? There's two different ways we could do this.
We are showing MEK is HME.
JC equals angle HEC. I think I've got this. Hold on. HEC, which is HME. Okay, so HEC is HME. So that's kind of how you're doing it. So we're showing KEM equals HME, right? All right. So HME is HEC, which is MJC, which is MFK. Which so MFK, which is MEK. Okay, so I got this. me just write it out. HME. MJC, which is MFK, which is MEK. Okay. Right. We have angle. HME is angle HEC, which is angle MJC, which is that should do it. Place ME's parallel to KH. HEC is HEC, I want to say, yeah, it's MJC, which is MFK, which is MEK. And that solves it. All right, let's move on to the next one.
I think I have another approach to this problem.
Okay.
So my approach is to prove that the segment EK is equal to the segment MH.
Okay.
And so we know that MH is equal to FG due to symmetry. So it's equivalent to prove that the FEKH is an isosceles trapezoid.
Yes.
No, I'm sorry. It's
Oh,
well,
that's true by the homothety. Well, that's true.
oh yeah.
Yeah. Because MJ is parallel to HE and MF is parallel to HG. So by the homothety, those are parallel. Oh, and then it's kind of obvious. Yeah. Okay. So they both work. I won't type it up right now, just because we spent a while on this. But yeah, thanks for sharing it. Yeah, I knew there must be an easy way to do this one. All right, let's try the next one. So we have, this one's kind of interesting. FB equals BD. This is weird. So D lies somewhere here. F and DC equals CE. So, okay, so first we draw D, and then we make the other 2 points like that. So I think it's like this, right? So DC equals CE, and FB equals BD. So let's make this a tall triangle. Oh, and we also want EF and BC to be parallel. So these 2 intersection points need to be parallel with BC. So how do we draw it so that that's true? Okay, so really, it's probably best to do it like let's call this like K or something. I'm going to try to draw an exact diagram. So BCD, so we want this to be E, and then we want to draw the parallel. Okay. And how should we do this? Okay, really we want to see where it meets the circle. So this should be F. Yeah, really we don't need, really we can delete this segment, I think. And it's like this. So this is A. Okay. All right, Right, and then we draw the tangent to the circumcircle DEF. Okay, so I'll just remember that these are both isosceles triangles, and so we might be able to just draw the incenter, because it would be the incenter of ABC would be the circumcenter of DEF. So interesting. Okay, so this we could call it I. It's the incenter of ABC and the circumcenter of DEF. And the tangent at F intersects AD at P.
Michael, I know how to construct the problem.
Okay.
Okay, you already did it.
Yeah,
But
yeah,
the useful thing is that AD is the angle bisector of BAC.
yeah. Because this is the incenter. Yeah. So yeah, so AP is the angle bisector, or AD is the angle bisector. And the perpendicular bisector of EF, it intersects, so it intersects AC at Q. So that would pass through I. And it intersects it at Q. And we want to show PQ and BC are parallel. This might be really easy. Let's see. So we could draw the end circle, because basically, well, no, that would pass through A then. But okay, so basically, since yeah, so we have BF equals BB and CB equals CE. So the angle bisectors of FBD and CED, but basically the incenter of ABC is the circumcenter of DEF, since hold on one second. Actually, now hold on, please. Okay, yeah, I know this is the angle bisector, but D lies on it because
You can use ratios to prove it. BD over DC is BF over CE. And since FE is parallel to BC, we have that BF over CE is BA over CA.
yeah, okay, so yeah, that's the angle bisector theorem. That makes sense. Okay. And okay, so there's a couple things we want to show. We use homotheties, so PQH. Yeah, this is so weird. So I think AF equals AG, is that right? Yes, by symmetry. So FG and AG are parallel and both perpendicular to AI. How do we show this? So by symmetry, G, J, and H are collinear, right? Because this is an isosceles. Oh no, that's not true. I mean, these intersect on AI, but yeah, that's not collinear. Maybe it's easier to define this to be parallel and then show that it's perpendicular to EF.
This whole problem can be just angle chase.
Okay.
So first we use Sparrow lemma, which can also be proved by an angle chase. It basically says that if we have these points F and D, such that BF is BD and CE is CD, it doesn't matter that FE is parallel to BC, then AI, FE are cyclic.
And that's just an angle chase, probably.
Yeah, it is an angle chase.
Yeah.
And for this thing, proving PQ is parallel to BC, we need to prove obviously that it is parallel to FE. And that is just equivalent to showing P is the in-center of AFQ by a bit more angle chasing.
Okay.
So we already have that AP bisects angle FAQ.
Okay.
And it remains to show that FP bisects AFQ.
All right.
And that can be angle chased since we know angle PFE, which is FDE.
I see. Okay. So PFE is F. PFE is FD, or PFE is FDE. Yeah. So that is just an angle chase. Okay. All right.
We actually don't need that AFIE is cyclic. I think since you can get PFE without it.
Okay. So, all right. So first of all, how should I define I? Let I be the in-center of ABC. And then we have BD equals BF and CE equals CD, means I is the circumcenter of BF. So BF equals BB, CD equals CE, implies I is the circumcenter of BF. And then now we use the ratios. So BD over DC equals BE over CE, which is equal to AB over AC, implies AB bisects BAC, and then that implies AI and B are linear. All right, so that's step one. And then we'll try to show P is the end center of AFQ. So, so angle PFQ is PFE minus QFE. QFE. And that is angle FDE minus angle QEF. Does that help? And we want to show that that's AFP. So AFP is like FDH. So FDH. So QEF is GEF is QEF is GDF. So this is FDE minus GDF. Which is angle GDE. And can we show that that's angle FDH? That's true by symmetry. Yeah, because FG and HE are parallel. Since by symmetry, since FG is parallel to HE by symmetry. Symmetry. And then angle FDH is angle AFP. And this means that P is the end center of AFQ. And once we know that, that means PQ bisects AQF. So from there, it's not hard to show that PQ is parallel to BC because we know QI is perpendicular to EF. So PQ bisects AFQ. And QI is perpendicular to EF. And that means that PQ is parallel to BC. All right. I'll add one more thing. All right, so we can move on to the next problem. So have we solved 3? Yeah, we've solved 3. Oh, this one is like a conditional. So let's see. This one looks interesting. So we could do this, this, or this. This one looks, I'm going to try Baltic Way. This is the midpoint of BC. Let's call it M. And we draw the circle. T is the intersection of it with AM. Whoops. It's driving me crazy. C, A, B. And we have T. Yeah, the thing is, once I create the new tool thing, I'd still have to rename stuff, but it would still be easier than doing all this. So it's T. D is the intersection point of the circle and the altitude from A. Okay, so if we reflect it, we should get the orthocenter. And X is the intersection of DT and BC. That should be X. T is the circumcenter of XDM. Call that X. And this is the center. This is P. And we want to show the circumcircle of OPB passes through the midpoint of XD. So this is O, and we'll take the midpoint of XD, and we'll call it F. We want to show that, so OPB. We want to show OPDF is cyclic. And PF is a right angle, right? Because it's the midpoint of. So we want to show POD is 90 degrees. That's another way to state the problem. Okay. So I feel like the problem is stated backwards a little bit. Like maybe it's easier to start with this circle. I mean, it's also the same. So I wonder, like, if this just, yeah. We have to prove this, but we could let DG be a diameter. And then, wait, is this problem trivial? We would need to show, it's not that trivial, I don't think. We would need to show that XDMG is cyclic. And then it would be trivial from there. So let me hide this. We want to show XDMG is cyclic. We really don't need point P or F. And let's think about that. So what do we know? XDMG. We get rid of point P for now. We don't need any of this. AG is, well, I can still show point O. So AG is parallel to BC. And is that just an angle chase? XDMG. It probably is an angle chase. Yes, because we want it, so angle XDG is 180 minus GDT, which is 180 minus GAM, which is 180 minus AGM, which is 180 minus GMC, which is, yeah. So the problem is trivial. Did I even type it up? What do you think? Or just go on to the next problem?
Let's go to the next.
Okay. It's too easy. So Pascal said there was another good problem on the Vietnam. This one might be harder. Let's see. This one looks like it might be easy. Let's check the Vietnam contest. So let's see. Vietnam TST. I think he was saying that 2023. Let's see. I think it's here we go. Here's Vietnam. So problem 3, we solved that with moving points. This was the other one that he said was good. You want to try this? Come on. There we go. So yeah, Vietnam, they like these 2-part problems. So let's see. Let's try it out. This, and then this is part A. Part A is often like trivial, but then part B is usually pretty difficult. So let's see what this looks like. It's a big problem. B is less than A is less than 90. So I'll think about how to do that. Yeah, very long statement. I agree. So we want this to be less than A. So like that. So we can make A close to 90 and B less than 90. So I is the midpoint of AB. This is I. And S is the intersection of A, B, and BC. All right. Looks a little like the Gauss line, maybe. This is S. And R is inside triangle SAB, so that ASR equals BSR on the bisector. Maybe it's better to do S at the top, but I'll see in just a second. So that should not pass through I. It's just an illusion. So I could make it pointy like that. And R is some point like right here, the bisector. Let me draw the foot of the bisector from this point on. but I want to make sure angle A is still less than 90. Maybe something like that. So this is R. Draw SF. On straight lines AR and BR and M, so is H the orthocenter? No, EF, BE and AF are parallel to RS. Okay. B parallel. Yeah, isn't this a long problem? This is very long. AR, BR. Will be interesting to see what it looks like in the end. We want this to be F. So we'll call that K. Not K, let's call it Z. I have no idea who would think of this kind of a problem. Watch it be like the easiest problem ever, and they're just trying to scare you by making it super long. I don't think they would do that though. So EF intersects the circumcircle of SAB. At 2 points H and K. This is really weird. H and K. Oops, didn't mean to do that. This is K. On segment AB, let M and N be such that AHM equals BHI. Interesting. So we have BHI and AKI. Okay, so we want to draw isogonals to HI and KI. I wish Z, like maybe I shouldn't even draw Z because I feel like it's getting in the way and stuff, but we want to draw isogonals. Okay. So why don't we do this?
You just draw medians. You don't have to complicate.
Oh, you're right. So it's just the median. So I draw the tangents at A and K, at B and K.
Also, as I see, for part A, C and D are irrelevant.
Oh, really? Okay.
Yeah.
All right.
You took the wrong tangents. It should be tangents at A and B.
A and B. But don't we want BHI? Oh, you're right. You are right. So BHI equals AH M. So this should be M. And C AKI. Okay, so then I just draw this. BKN. All right. That's M and N. And okay, so C and D are irrelevant, like you mentioned. And let's hide this, and draw those. Prove that the center of the circumcircle of SMN lies on a fixed line. And does K, what is K? Does K also lie on it, or is that just, no, that's this circle. And does F lie on that? No, F does not necessarily lie on that. So we'll just have to remember that. Lies on a fixed line. So as R varies, we want to show J lies on a fixed line. Okay. And it looks like, is that just going up and down? It almost looks like it's curving a little bit, but that might be an optical illusion. That's not a line. So somewhere, something is off somehow. N is wrong. Okay. We want BKN to equal AKI. So why is N wrong? Does BKN equal AKI? Oh, because N, no, it should be on AB. Are you sure N is wrong?
Yeah, N is on GK, not GF.
Oh. And that should fix it. All right, good catch, Abdul Heel. So this is N. And now it should be on a line. And I wonder if those circles, I don't think they're tangent, because I think there's some other intersection point. Maybe they are tangent. So we could check. It looks like the circle stays not the same circle. It's like a line. Is it parallel to S?
It looks like SMN is tangent to ABC.
Okay.
That would just mean that SN and SM are isogonal.
Okay. So, okay, so we want to show, so if SM and SN were isogonal, that would mean that circle's tangent. And then that would solve the problem because J would lie on the line connecting the circumcenter of ABC to S. Okay. And maybe this is the isogonal line lemma or something. Not sure. See, the problems are worded so long, but yeah, it's simpler than they look. Okay. How do we show those are isogonal? Let's try this. Don't think that does anything. Maybe we could show BM over AM. Well, no, that won't work. Or sine BSM over sine MSA.
Why wouldn't that work? We have BM over MA, kind of.
Oh, that's true.
It is HB over HA whole thing squared.
Yeah. So yeah, maybe that does work. So we want to show that BM over MA like times BS over SA or something like that is equal to like AN over NB times like SA or SB or SA or something like that. So I think that could do it. But that would involve BH over HA and BK over KA, right? I think. How do we calculate, what's the formula for BM over MA?
In terms of what?
Is it like BH over HA squared?
Yeah.
Or...
Yeah, it is.
Okay. So we'd have BH over HA squared. And then we'd have BK over KA squared. And if you combine those, we want to show we want to like show that that's BS over AS squared or something like that. I don't know exactly. And BS over AS by the angle bisector theorem is AZ over ZB. How do we define E and F? So the E and AF are parallel to the bisector. So it might help to draw the midpoint of this arc because that will be collinear with GI and J. Well, where did I go wrong? Oh, no, it would be the center of the circumcircle ABC, which we haven't actually drawn. So O, L, I, G, I think are collinear. And this is collinear. Oops. That doesn't look collinear, so something is off. Let's see. Oh, I don't know why I didn't think it was collinear. Okay. That is collinear. Here's where we want to use the parallels. So AF is parallel. So if we let BE and AF meet the circle, then we get an isosceles trapezoid. I wonder if it's kind of interesting. We get when we intersect this and this. Nothing really. Is this the antipode of P? Probably not. Yeah. I don't know if that does anything. If I draw HI, like maybe it would help to draw these 2 points. Let's see, if I let SM meet circle. Okay, so EH and AH, how do we find that? H is just defined in a weird way, that's the issue. So yeah, I'm trying to use the fact like BHAP is harmonic. So yeah, like PI is just the median of BPA, but I don't know if that's helpful. I don't think those actually, yeah, those don't actually concur. Yeah, I don't know what to do about E and F. They're just so weird. So arc BL equals arc LA. Oh, you know what? I really should draw. I feel like I should draw these points because then, so we know BL equals LA. Those two arcs are equal, and then that would mean QS equals ST. Oh, I should have let it intersect the big circle. Let's delete that. Yeah, QS equals ST. So we have isosceles trapezoid BATQ, and EF is kind of just like the intersections of AR and BR with the sides. That seems more like intuitive, or that seems more easy to understand to me. So SL, it's like where we take the midpoints of each of the arcs, and so we can almost use, we can basically use like, so R is not in the center. Like this seems like almost a generalization of a problem that started with the center. So BH over AH, maybe we could bash that somehow. That's like, yeah. All right, so we are almost out of time. Just one more minute left. All right, so I am going to stop it here. So thanks everyone who participated on the session. It was a lot of fun, especially that first problem. I'll have to think of some more contests because yeah, I feel like a lot of the problems are too easy this time. So I might repeat some contests if I feel like we probably don't remember the solutions. But yeah, so thanks for participating, and everyone who's watching, thanks for watching. If you want to join us in the future, feel free to email me at mgreenb801@gmail.com. We meet every Sunday at 8 a.m. US Central Time. So thanks again and have a great day.